Right. So now let's look at question number 15, part B of Combined Mathematics 2024 A-level paper. Right. So here we have to first show using this substitution that this integral is equal to half ln 3. Right. We will do that part first. So let's use the substitution they suggested. U is equal to x plus square root x squared plus 3. Then du is equal to what? 1 plus 1 over get 2 square root x squared plus 3 times 2x, right, and dx. So let's simplify this. So what do you get? Du 2 cancel 1 plus 1 over square root x squared plus 3. So not 1 over x over square root x squared plus 3 dx, right? So now let's simplify this a little bit by taking the common denominator. Then you will see the numerator will become what? The u term. So that will make it easy for us to apply the substitution. So let's simplify that a little. So we have du is equal to square root x squared plus 3 plus x over square root x squared plus 3 dx, and we know this numerator part is u, so that means this is equal to du u over x squared plus 3 dx, or we have du over u is equal to dx over x squared plus 3, right? So now let's apply the substitution. So when limits are 0 and 1, so we need to find the new limits of integration. So when x equals 0, what is u? U is 0 plus 0 squared plus 3 inside the square root, so square root 3. Then the upper limit is when x equals 1, u equals 1 plus 3 inside the square root, so 3. So those are our new limits of integration, right? So now let's apply the substitution. So lower limit becomes square root 3, upper limit becomes 3, and notice that dx over square root x squared plus 3 is equal to du over u. So this whole term we can replace by du over u, that is same as 1 over u times du. Right, now we can find this integral. So what is the integral of 1 over u? That is natural log of absolute value of u. Then apply the limits. So we have ln 3 minus ln square root 3. This is same as what? Ln 3 over square root 3. We'll just combine the natural log terms. If you have a difference, you can write it as a quotient. So then this turns into natural log of square root 3. And now let's look at our answer. We want to write the answer as half ln 3. right? So now it's just properties of log. Square root 3 write as a power. That is what? 3 raised to half. Then apply the exponent rule for logs. You can bring the exponent to the front. Then you get the answer. So you have half times ln 3. Right. So that part is done. Okay. So then let's see what is the next part. So this part is done. Then they say j is equal to this integral, and using integration by parts we have to show this relationship. 2j is equal to 2 plus this integral, right? So we'll start with what? J. J is equal to this and use integration by parts as they suggested, right? J is equal to 0 to 1 square root x square plus 3 dx, right? So here there's no option. You have to take u as what? Square root x square plus 3 and dv as dx. Then du becomes what? Du becomes x over square root x squared plus 3 dx, and v is equal to x. So now let's apply our integration by parts formula. So that gives us what? That gives us j is equal to uv. So x times square root x squared plus 3, we have to apply the limits 0 to 1 minus v times du. So x, then x squared plus 3, and x multiply, so you get x squared in the numerator dx, right? So now let's apply the limits of integration here. So when I apply 1, I get 1 times square root of 2 square root of 4, so that gives you 2. Lower limit gives you 0, so that just becomes 2, right? 2 minus this, right? Okay. Now what is the expression we want to show? 2j is equal to 2 plus this one, right? So let's write that somewhere. We want to show 2j is equal to 2 plus 0 to 1 3 square root x squared plus 3 dx, right? So let's see, we already have the 2 here, so that is done. We need another j term and this integral. So here we need to somehow simplify this integral. No point in doing integration by parts again, then we won't get something like this, no? So here we have to simplify the expression inside of this integral to create the j term and this new integral. So what is j? So we want to create this 0 to 1 integral of square root of x squared plus 3, right? This we can do by doing what? By adding plus 3 and subtracting 3 from the numerator. So notice that 0 to 1. Now I'm going to add plus 3 and minus 3. So then it's still the same expression, x squared plus 3 square root of that and then dx. Then group the first two terms and break this into two integrals. So j is equal to 2. That's the minus sign. Then first integral is 0 to 1 x squared plus 3 over square root of x squared plus 3 dx. And the second integral is 0 to 1 3 over square root x squared plus 3 dx. And remember, we want this integral and another j. So here we created that integral, and when we simplify this, you will see this is going to be j, right? So let's simplify. 2 minus 0 to 1, and here what happens? You have x squared plus 3 to the power 1, and square root means what? Power half. So when you apply the exponent rules, this will simplify into what? Square root of x squared plus 3. Then we have that, and minus minus becomes plus. Then 3, this one dx, right? Then this term we know is what? That is j. 2 minus j plus 3 over square root x squared plus 3. So that integral. Now we have the answer. Move the j term to that side. So 2j is equal to 2 plus this integral. Right. So we are done with that. Then the final part. Final part is what? We have shown this. We have shown this. Then deduce the value of j. Right. Right. Okay. We can use our first result. This integral is what? Half ln 3. So then this integral becomes what? You take the 3 out. So then 3 over 2 ln 3. This part is just going to be 3 over 2 ln 3. Right. So 2j equals 2 plus, let's take that 3 out, 0 to 1 over square root x squared plus 3 dx. So from the first part we showed this is equal to half ln 3. So we'll apply that. Half ln 3. Right, now we want to find j. So just divide everything by 2. So 1 plus 3 over 4 ln 3. So that is what we were supposed to show. Right. So that is part B of question number 15. Right. Next we will look at part C.